Hey guys, BuildZoid here, and Tech Power Up has posted a bunch of RTX 4070 Ti reviews, and so, as is typical for me anytime Tech Power Up posts a bunch of GPU reviews, I go and check out the PCBs. That's just what I do. Like, for a very long time now, anytime there's a new GPU launch, I just go and check out the PCBs. So that's what we're going to be doing in today's video. And I'm just going to be sharing my thoughts on the various RTX 4070 Ti PCBs. So let's get into it, starting off with the RTX 4070 Ti Gaming X from MSI. No, not the teardown. I don't care. Heatsinks can be replaced. PCBs, not so much. That's basically why I care about the PCB so much. Anyway, let's take a look at the front. So, the first thing I notice is MSI has managed to squeeze in a fuse onto a 4070 Ti, which is quite the achievement because this stupid connector makes it really difficult. And the reason this connector makes adding fuses to your GPU really difficult is that this connector goes into a single massive 12-volt power plane. So you can't really fuse it because the fuse got to be like 30 amps or something, and at that point, like, you're kind of wasting your time. But so what MSI has done here, well, you do have a fuse on the PCIe slot. This is a little 12 amp fuse. And the idea behind this is that, well, the PCIe slot probably powers like 1 or 2 phases of vCore, maybe a phase of memory, maybe nothing. Maybe it only powers like the minor voltage regulators, like whatever the hell this is and that over there. So, like, fusing those makes sense, because the problem is, like, if you have too many power stages hooked up to a single fuse, like, that fuse ends up having to be completely massive, and that kind of defeats the purpose of having a fuse in the first place. So yeah, since the PCIe slot isn't really powering a whole lot of stuff on this card, they can put a little 12 amp fuse on that, and that's nice. So if any of your, like, if anything connected to that fuse fails short circuit, that fuse will minimize the amount of damage that can occur. Even if your power supply has a really slow overcurrent protection or short circuit protection. Anyway, the other fuse is this 20 amp fuse that they have specifically for the memory power delivery, which is actually a very that's a really good idea. And the reason MSI is only putting it on the memory power delivery is because you can't really, or like, they probably could, like, split the 12-volt power plane after the, the 16-pin connector, but it's not particularly convenient to do that for, like, the vCore power delivery. So they've just split off so you have, like, a separate 12-volt region for specifically the memory, and that gets fused with that 20-amp fuse. This is still very helpful because, funnily enough, when vCore VRM fails, they can kill the GPU core, but it's relatively rare. I think the reason why it's relatively rare is because you have a lot more output filter, like you have a lot more bulk capacitance on the core power. The core has a lot less resistance, so getting the voltage to, suddenly spike up on the output of the vCore VRM is a lot more difficult than it is on the memory power delivery, because the memory, when it's not running, will regularly have like 10 plus ohms of resistance. And so when you have a shorted high side MOSFET and, like maybe 2,000 microfarads of output capacitance, it doesn't really take that much energy to get the voltage to go really, really high when you have, 12 volts shorted straight to the output. Whereas on vCore, where you have thousands of microfarads of capacitance, like sometimes, what is this? 1, 2, 3, 4, 5. This is probably like 8,000 microfarads of just bulk capacitors. There's probably like 10,000 microfarads of capacitance in total in vCore. So you have one shorted, MOSFET, like, it's going to take quite a lot of energy to get the output voltage of the vCore VRM really high. But for memory power, there's not that much capacitance. The memory chips are a relatively high resistance path to ground. So it's really quite easy to, like a 12-volt, like, short-circuited high-side MOSFET will spike the voltage on the memory power to 3 volts, and then everything dies. Because you basically, like, the problem with semiconductors is if you apply a high enough voltage to them for an impossibly short, like, for if you apply a high enough voltage, you'll just kill them instantly. So the fact that you get like a 3-volt spike or something like that, that's enough to kill all of the memory chips, the entire memory controller, and like the whole GPU is scrap at that point. Well, yeah, no, the GPU is scrap. You can use it for parts, but the actual valuable part of the GPU is dead. And so having this 20 amp fuse specifically for the memory makes a lot of sense, because the memory VRM is the most likely thing to completely destroy a GPU. vCore VRMs vCore VRM failures, as long as the PSU isn't too slow and the person who the card failed on didn't try to power cycle it too many times, is pretty unlikely that your vCore VRM is going to kill the core. But your memory VRM killing the memory chips and the memory controller, which is part of the GPU core, yeah, that's actually very, very common. If the memory VRM fails, that it'll just destroy everything. So that's why the fuse is on the memory VRM and on the PCIe slot, because fusing the vCore isn't particularly doable, but this is still like a really good insurance for improving the repairability of the board. So yeah, does that look like we have dual BIOS? Oh no, actually, is it dual BIOS? Oh yeah, it's dual BIOS. That's neat. And in terms of the actual power delivery, we've got just some SMD, technically these are SMD capacitors, but they're like cans. We've got a bunch of 820 microfarad can capacitors, 5,000 hours at 105 degrees based on the labeling. I don't recognize the manufacturer. These MSI tends to use a lot of Nippon Chemicon, so it's probably those. We've got some Alpha and Omega Semiconductor DR MOS components, BLN3s. I don't immediately recognize those, but I'm pretty sure Tech Power Up actually tells us, yeah, these are 55 amps, so nothing too special. And we've got what, like 10 of them? Yeah, 10. So we've got 10 power stages for vCore, controlled by a UP9512. So this card would be very easy to vault mod. Yeah, this would be very easy to vault mod because you just have that UP9512. And that chip just uses PWM vid, so if you want to adjust the output voltage of the vCore VRM, you just put a potentiometer across the ref in pin, and you disconnect your ref out. Is it ref out or ref ADJ? Ref ADJ. There's a pin called ref ADJ, you disconnect that, and then you put a potentiometer from VRef to ref in, and you can adjust the voltage. You can also tie the ref in, you can also put that potentiometer from ref in to ground, and then you get negative voltage offsets instead of positive voltage offsets. Yeah, I'm not a big fan of I'm not a huge fan of how the filtering is set up. We have some multi-layer ceramics missing behind the core, though that's pretty standard. They did opt for this 470 microfarad SP caps instead of 220s or something. There's some optional multi-layer ceramics that MSI decided not to bother with. I wouldn't expect this to have particularly, if you measured this card with an oscilloscope, I don't think it would be particularly amazing compared to some of the other 4070 Ti's, because I couldn't help myself. I've already checked out the other PCBs, so I already roughly know how the others look. But I do like the fact that MSI has, put the fuses on the card. The VRM, actually, let's do a quick calculation of just how much power a 4070 Ti, or how much current a 4070 Ti pulls. Where's the power consumption here? Power consumption. Yeah. Okay, so this card can actually hit up to 300 watts. But normally it stays around 275. But we'll take the 300. I still don't know how much power GDDR6X consumes. Now, NVIDIA GPUs actually have really high memory power rail power draw. I think because NVIDIA uses that power rail to just straight up power the memory controller, compared to AMD where you have a separate memory power rail and a memory controller power rail. I'm pretty sure NVIDIA GPUs just straight up use memory power to run the memory controller, so they put a lot more load onto their memory VRM compared to AMD GPUs, which makes things a bit awkward when it comes to estimating the memory power draw for me, because I have good data for AMD GPUs, not so much for NVIDIA. Anyway, 300. Let's take off 30 watts, right? It's better to Yeah, let's just take off 30 watts. So we'll say 270 watts for the core. I need to know the voltages. Card runs up to 1.1 volts, so we'll just divide this by 1.1 volts. This is not at all accurate. 245 amps-ish. So, it probably, like, the thing is there's obviously power losses in the power delivery, so if the card is pulling 300 watts, it's not actually outputting 300 watts. There's probably, like, 30 watts of heat loss. Then there's also the fact that you've got the memory. But, yeah, so something over 200 amps. So the stock, what is it, 10 power stages are going to be, what, 20 amps per power stage? And yeah, that's no problem with these 55 amp parts. So it's probably going to be a bit less than 20 amps per power stage. So yeah, like this, for stock operation, this VRM is definitely more than enough, which isn't really that surprising. Yeah, so let's move on to the next card. So, like, I like the fuses. I'm not very impressed by the, like, filtering configuration. Then again, without oscilloscope measurements, it's impossible to say how much of an impact that actually has. So, yeah, anyway, let's move on to the next card, which I guess will be this palette card. Hopefully, less of a disappointment than the what was it? It was the Palette 4090 that was just, like, super downcosted. Anyway, so we've got the Gaming Pro OC 4070 Ti from Palette. Through-hole inductors. This might be less prone to coil whine than some of the cards that use SMT inductors. But, yeah. Other than that, there's really no difference to that. Ooh, there's, like... Well, you've got the option to add some extra filtering if you feel like it. That's kind of nice on the back, instead of just the multi-layer ceramics. 330s behind the core itself. Also, those little multi-layer ceramics that MSI didn't bother with, Palette didn't bother with either, which really doesn't surprise me. We've got a UP9512 over there. Oh, it looks like NCP 45492 for power monitoring. That's interesting. So they're not using the... Yeah, that looks like 454. Yeah, it looks like 45492 instead of, wasn't it 45491 for past cards? I'm assuming the MSI card had that chip as well. I just didn't bother to look at it. There's a UP95. Actually, we're just going to 9529. I've not seen this controller in use yet. Let's see, Ubic, Semi. Hopefully their website is not like... Oh, hey, look. Do we have public documentation? 3-phase PWM buck converter. Hey, public documentation. Okay, I need to save that. These guys sometimes like put up a data sheet and then they take it down, or like they expire pages over time. So there's like some old controllers that used to be on their website, but they're not anymore because you're not supposed to use them. So yeah, that's kind of annoying. Though you can usually find those data sheets on like other data sheet website, but yeah, anyway, so we've got this, VREG Type 3 with PWM vid interface, so absolutely trivial to vault mod, which is nice. So if for some reason you wanted to overvolt the GDDR6X, you could very easily. You just need to feed... Oh, is it... No, VREF is 2 volts output. Ref ADJ is what the... Like, this is what is used for the dynamic voltage by the GPU itself. Go away. Ref in is the pin that allows you to... Like, whatever voltage is applied to ref in is the output voltage of the voltage regulator. Or, like, that's the target voltage for the controller. That's what the controller is going to try to hit in terms of output voltage from the VRM. Anyway, so that's controlling the memory VRM, which on this card is a 2-phase, which is like this over here and that over here. We've got more. These are APAC capacitors. Nothing wrong with those. Those are like a Taiwanese brand. Very, very popular on like lower cost motherboards and GPUs. Like, the thing is, these are polymer capacitors. Like, polymers are great because they don't really have any catastrophic... Like, they don't tend to have catastrophic failure modes unless you, like, run them backwards or apply way too much voltage to them, which, yeah, this is not really a concern. So, anyway, then we've got on-semiconductor power stages. Got a 302150, so that's, I think, a 50 amp DRMOS from on-semiconductor. And in total, we've got 9 power stages. So a little bit worse in terms of current handling capability than the MSI card. Also somewhat worse in terms of filtering, I think. Yeah, because MSI at least had like a bit more capacitance directly behind the core. I'm not gonna actually like go and count how many bulk capacitors there are. That's wasted time. I don't see any fuses, which isn't surprising. These days, it only seems to be MSI that's still putting fuses on their cards. Mostly because, yeah, this power connector makes it really awkward. Like, you need to... And also, I'm pretty sure this is based on a reference NVIDIA PCB. Yeah, like, you have options for 8-pin power connectors that aren't used. But, yeah, like, I don't see anything... Like, this isn't impressive, but it's not... That's a nice basic PCB, in my opinion, right? Like, for your 4070 Ti. Yeah, don't really have any complaints for this. There's a lot of input filtering, but that's standard on NVIDIA GPUs. So, yeah, that's kind of that. Nothing particularly special, nothing particularly terrible, but if you wanted to mod the power limit, like there's your shunt resistors. But if you wanted to mod the filtering, then yeah, you do have these very convenient pads. That like I wish MSI had like on the 4090 Supreme X, MSI has like a whole bunch of unpopulated capacitor pads, which like if you wanted to, further improve the output filtering of the VRM yourself, then you could with that. They don't have that on the 4070 Ti. I'm a bit, upset that they didn't do the same. Like they didn't have to populate them, just kind of leave them available. But anyway, let's move on to the PNY 4070 Ti. This looks, yeah, okay. I think the palette card was like a reference PCB, or let's pull up the palette card again, because this card, like, you can obviously see that this has a lot of padding on it, right? Like, all of this is just, like, they just added up some extra PCB up top for their, I guess, the RGB and the fan headers. They've also added some padding on the end for some reason. I don't know what that's, like, what purpose that is supposed to serve. This curve right here makes me think blower. Like, that really makes me think that there's going to be, like, a 4070 Ti blower card, because that is a very suspicious curve in the component layout. Oh, that's not present on the palette card. Oh, no, it is. It is present. Yeah, because palette jammed a bunch of stuff in the, like, in the empty space on the PNY card, right? Because, yeah, you can see it. You've got that capacitor pad and this capacitor pad. And that's this one, and then this is all empty. Whereas palette actually used all that empty space for, like, I think a 5-volt regulator and I'm guessing RGB controller, some, RGB header. So palette decided to shove all of that into this space, whereas PNY decided to put it up sort of across the top edge. In terms of filtering, this looks exactly the same as the palette card in terms of power like how many power stages we got, same as the palette card. What do we have on the back? Different capacitor, yeah, different optional capacitor padding. So I guess not. Yeah, the very blower. I'm thinking, oh wait, no, they have that looks like a controller for the RGB. So yeah, looks like PNY's done kind of the same thing there as palette did. What's the bulk capacitors? These are 220s, yeah, EU. These are the cheap option. This is the cheap option. So yeah, 220s. UP9512 over here. I'm surprised that NVIDIA is still doing this like PCB layout, considering that I think most of the power for the V-Core VRM is coming through the 16 pin. So, because like the reason why some GPUs will have the V-Core VRM by the PCIe slot and some GPUs will have the V-Core VRM like over here is basically if you put your VRM over here, it's very easy to pull 12-volt power from the PCIe slot. Yeah. There is one downside to this, like this PCB layout, which is you have a bunch of memory chips right above the PCIe slot, and these memory chips are kind of susceptible to the PCB bending under the weight of the heatsink. And then the BGA breaks, either by ripping pads off the memory chips or ripping pads off of the GPU PCB, and then your memory stops working. This is like, yeah. Also, as it's especially bad if you're like shipping an assembled computer, that there's a chance that these memory chips end up broken from the card bouncing up and down in the PCIe slot. Um, Arguably, unreinforced PCIe slots are actually less dangerous to the GPU. Right? Because if the PCIe slot itself has more flex to it, that puts less flex into the board. Because if the PCI, like, if the gold fingers are being held, like, completely still, then all of the bending is going to happen, like, on the PCB itself instead of in, say, the plastic of the PCIe slot. But, you know, just don't bounce your computer around if you're moving it, or remove the GPU before moving it, right? That's really the only time that's a major concern. And I think it is worth bringing that up with 4070 Ti's because these things have substantial heat sinks, right? So the fact that like these memory chips are down where they are, yeah, like that is a bit of a structural integrity hazard for the BGA of the memory chips down there. And we've not seen any cards put any underfill on them. Actually, did the MSI might have put the memory chips further away from the PCIe slot? Wrong freaking page again. Yeah. Yeah, no, MSI's moved they've kind of moved the everything up from the PCIe slot, so that could help a bit, right? Like basically you don't want your fragile BGA devices close to the PCIe slot. That can help a little bit with the physical robustness of the card. At the cost of the card obviously being bigger and potentially not fitting places that the smaller cards fit. But anyway, let's take a look at what Gigabyte has done, because the PNY card really isn't anything special. So, Gigabyte. Let's see. We've got 10 power stages, right? Yep, 10 power stages, SMT inductors, so this thing might coil whine a lot. 150 nanohenries, which is a very, very low inductance, generally speaking. Well, actually, it's not that low. GTX 590s used 110. Mostly because there wasn't any space for anything bigger, but... yeah, so 150 nanohenry inductors, which is pretty close. I think the through-hole ones are probably like 220s. At least that's what they were on a lot of the older NVIDIA GPUs. No fuses on this card. Dual BIOS switch up there. We've got actually, we do have a fuse by the PCIe slot. Did they bother to put a fuse for the memory power? I don't think so. Yeah, it doesn't look like it. This card has 3-phase memory power. Decided to populate this over here and then this. I do like what Gigabyte has I actually kind of like what Gigabyte has done with the filtering. This is one of the only cards that has the multi-layer ceramics directly behind the core, almost. Actually, yeah, basically fully populated, because you might be looking at like these two pads over here and this pad over here and going like, wait, that's not populated. Yeah, the problem with that pad and these two over here is that these pads are supposed to connect to the pad that is occupied by this SP cap, and these are 560 microfarad SP caps, so that's a lot more like bulk capacitance directly behind the core than what you see from some of the other manufacturers, right? MSI was using 470, Palette was what, 330s, and PNY was on 220s, so potentially somewhat better voltage regulation on, like, I would expect this card to have better voltage regulation. If you took a oscilloscope, it might be very slightly better. And the reason I say very slightly better is because this is not that much of a difference, right? Like, they've added some extra ceramics, which will be like, yeah, this will be like 1 microfarad. This will be like maybe 4.7 or something. And then, what, like 200 microfarads of SP caps, or 300 microfarads of SP caps. Like, this is not actual per SP cap. It's not that much of an improvement. They could also be a bit lower ESR, or maybe a lot lower ESR, but I don't think it would be enough that it would make a really big noticeable improvement. However, if you're into modding GPUs, then like Gigabyte has given you plenty of space for extra capacitance. Yeah, and then the card might clock a bit higher. Might. Keyword might. Like, it really depends. Well, generally speaking, most modern NVIDIA GPUs have very noisy power delivery in terms of just, like, voltage regulation, because NVIDIA takes a really aggressive approach to their load line, as in they don't actually, like, they have an AC load line, which basically means they only have V-droop when the current draw drastically changes. And the reason NVIDIA does this is because if you had literally no load line whatsoever, the voltage regulator has the potential to start, like, oscillating due to the current spikes going up. Like, if you have one sort of uncontrolled transient occur and then immediately another one as the voltage regulator is trying to recover from the first one, that tends to cause massive issues. So to work around that, actually, I wonder if we could pull up I don't think the UPI's documentation is going to be very good for this. There's a really good example of AC load line in the monolithic power systems documentation for, I think, the MP2888. Yeah, no, or I don't think we're going to find anything. But basically, like, NVIDIA GPUs will only, or NVIDIA VRMs will let the voltage sag during a rapid current transient. They'll let the voltage sag and then slowly recover from that. Is the way the VRM is designed to work. And the reason they do this is because if you don't let the voltage sag and the voltage regulator keeps trying to fight the voltage deviations, you could end up with the whole, like, control loop getting kind of unstable if you have if the transients are coming at, like, exactly the wrong time. And so, yeah, the idea is just, like, the VRM basically sort of, like, it's intentionally slowed down, but doesn't actually have, like, a load line. Like, it doesn't have a permanent load, like a DC load line where you just intentionally let the voltage drop by a certain amount. The end result of that is that modern NVIDIA GPUs have just absolutely massive deviations in their average operating, like the voltage going to the core just sort of jumps uncontrollably from very low to very high constantly, and you might be like, wait, how does the GPU not crash if the voltage regulation is so relatively bad? And the answer to that is NVIDIA GPUs employ a lot of clock stretching. So anytime the voltage is way too low, the card just kind of slows down without telling you about it. And anytime the voltage is too high, it actually doesn't do anything, because if the voltage is too high, that doesn't cause blue screens. So that's fine. Like, it's not a problem if you have overshoot. It's a problem if your undershoot is too low. But yeah, so this might be somewhat better voltage regulation than some of the other cards. But yeah, and like, if I was buying a 4070 Ti, I'd be very tempted by this PCB because of the extra capacitor pads. Also, I did a terrible job of explaining AC load line. Actually, you know what? Screw it. We're just gonna pull up the MP2888 documentation, assuming that it hasn't been taken down. Yay, it hasn't been taken down. Come on. Yeah, so if we scroll down, yeah, and there. So basically, here's a DC load line, and this is, like, what's used for CPU, or, yeah, this is generally what you see used on, like, CPUs and AMD GPUs. And basically, what you can see here is the pink trace is the current output of the VRM. And you can see that this is a current load step of 0 amps to 150 amps. And basically, you have the output voltage of the voltage regulator as the green trace. And what you can see is that our voltage basically, is set to 1 volt, and there's a 0.5 milliohm load line. So when the current jumps up from 0 amps to 150 amps, the output voltage of the voltage regulator drops by 150 millivolts, and the voltage regulator doesn't do anything about it. The voltage is now at, like, 0.85 volts, and that's just, yeah. And once the load releases, the voltage comes back up to 1 volt because the current draw has gone back down. Now, what's used on NVIDIA GPUs is this right here, an AC load line. And what you can see is you still get that downward spike, right? But then the voltage regulator, like, pulls the voltage back up. And then you get this big overshoot at the end, and the voltage regulator pulls the voltage back down. So this right here is just kind of like not trying to fight what's happening to the voltage due to the current draw. And here the voltage regulator is intentionally, like, temporarily allowing the voltage to get low and then pulling it back up again. And then when it shoots up, then pulling it back down again. So that's like the difference between the DC load line and AC load line, at least as how NVIDIA has it implemented, because I think Intel also uses the terminology DC AC load line, but it does not work the same way. But yeah, so because of the AC load line approach that NVIDIA takes to their voltage regulation, their peak to peak is absolutely horrendous, because with like this, right, you basically, like, the voltage, like the minimum voltage is like 0.85 volts and the maximum voltage is like 1 volt, right, because there's no massive overshoot at the end. With the NVIDIA approach to voltage regulation, you have like 0.85 volts. Actually, this is lower. Wait. Oh, no, they're not. The traces aren't on the same offset. But so you'll have like the same initial, downward spike. And then you'll also have this really tall upward spike. So the peak to peak of this will be like 300 millivolts probably, whereas this is peak to peak like 150. So in terms of peak to peak values, NVIDIA voltage regulators are very, very noisy. Because they just kind of go like, yep, there's undershoot and overshoot, and the chip will deal with it, is the approach NVIDIA takes. So actually, Ryzen CPUs do something very similar. So yeah, it's not like a new approach to... Well, actually, I think NVIDIA is the first to really start doing this a lot, because I think they started that with like the 10 series, but... Anyway, or even 900 series, because 900 series cards are incredibly noisy as well, but anyway, so yeah, if you have better capacitance like these, like more capacity, like better output filtering, which is both a combination of like potentially lower inductance inductors, which would reduce the upward spike over here, also speed up the recovery time on this part over here if you have lower inductance inductors potentially. And then just having like more capacitance will reduce how low this spike will go a little bit, or a lot, depending on how big the difference in one, capacitor configuration is to another. And it'll also reduce the upward spike at the end. But anyway, so yeah, I'd expect this Gigabyte card to basically get a bit better voltage regulation than, say, the MSI PNY palette cards. Not that it will like noticeably affect the overclocking, because again, NVIDIA cards just clock stretch when the voltage is too low. So the funny thing with the clock stretching is if you cap mod modern NVIDIA GPUs, as in like add extra capacitance to try and improve the voltage regulation, you won't necessarily get an improvement in terms of overclocking headroom, but you might get a slight improvement in terms of FPS. And when I say slight improvement, it's like 1%. It's very, very small. It is, like, noticeable. If you're running benchmarks, it's noticeable that, like, the card is performing a bit better. It's not noticeable in terms of, like, oh, you'll notice that the FPS is higher. It's too small of a difference for that. But, yeah, like, this, like, basically, I like this PCB as, like, for modding. This looks really... like sort of the most friendly PCB for that. Also, the output filtering for the memory is a bit better than what you have on the other cards. Actually, this is for vCore over here, but this is for memory. This is for memory. On the front of the card, yeah, we've got SMD polymers right up against the core for vCore over there. So I like what Gigabyte has done with the filtering on this card. I don't think it'll Oh, they've also got a lot of input filtering capacitance. Those are 270 microfarads, whereas some of the other cards we've seen so far were like 100, 180. So, yeah, Gigabyte splurging on those capacitors. And SIC 653s, which I think are like 50 or... No. Shay. Are these public? They might not be. They aren't. Oh boy. Yeah, so the 653s aren't public. Well, that's annoying. So they're probably 50 amp parts. Yeah. So similar to what we've seen on all the other cards, just different brand. Doesn't really matter. Yeah, so I like what Gigabyte has done in terms of the capacitors. In terms of power handling capability, it's the same as the MSI card, so a bit better than the Pallet and the PNY. And there is one fuse on the PCIe slot. I don't think this is... This is not... the fuse on the PCIe slot is not as good as the fuse that MSI had on the memory power. Yeah, I think fusing the memory power delivery is a lot more... like, you know, if you're going to put a fuse on something, on the memory power delivery is probably the best option. Putting it on the PCIe slot is like, I don't think... I guess it's to protect your motherboard, but that's really, like, it's not really that much of a concern. So, yeah. Anyway, let's move on to the next card. So I guess the Supreme X from MSI, I'm assuming this is the same PCB as the gaming with just, yeah, all of the power stages populated. So we've got, what, 12? Yeah, so we've got 12 power stages. Also, the UP9512, by the way, this is like an 8-phase controller. Like, it's straight up, maxes out at 8 phases. So, anyway, like, this is probably going to be... like, the funny thing with NVIDIA cards is actually this will probably be an actual, like, 8-phase in terms of how many phases are hooked up, because on NVIDIA cards, having, like, asymmetrical phases where, like, some phases have 2 power stages in them and some phases only have 1 power stage in them is actually kind of common. Anyway, this does have the same fusing as the gaming card did from MSI, so that's nice that, you know, you've got the fuse on the memory, you got the fuse on the PCIe slot, not for VCore. VCore doesn't have a fuse. The input filtering, yeah, is not the back, front, there we go. Like, these are 100 microfarads, so yeah, there's less input filtering than we had on the Gigabyte card, but I don't really think that makes too much of it. Like, input filtering doesn't tend to make too much of a difference unless you're looking at something like a 6900 XT, where the reference PCB just has, like, 4 bulk capacitors, and that's it. Which is just not, like, that's, like, less input filtering than what you would find on, like, a 100-watt GPU from 10 years ago. And I'm serious about that. Anyway, 3-phase memory power on this, still just the polymers for filtering the memory. Yeah, no SP caps for filtering the memory power, just polymer, like, just can capacitors and multi-layer ceramics. UP95. Oh, we've got a US 56, what is it, US 5650? Yeah, that's the other chip. So there's the NCP 45491, the 45492 apparently, and there's also the US 5650, and that's what NVIDIA is using for shunt monitoring on the newer chips. I mean, on the newer GPUs, but like, this chip's been in use since, like, the 20 series. So when I say newer, I mean, like, before the 20 series, you had the INA 3221 as well as the INA 219, and after the 20 series, you have the US 5650 and the NCP 45491. Controller's still the UP9512 over there. Yeah, this is literally the same PCB as the gaming card. They've just added a few more power stages, and I think maybe a couple more bulk capacitors. I wonder what inductance these inductors have. I do wonder about that, because these are 150 nanohenry, but yeah, these have, like, unhelpful labeling or unhelpful branding in place of just an inductance number. It's probably, like, it should be on the side of them, but we don't have a photo of the side of those inductors. So yeah, and then same power stages, the BLN3s. And finally, we've got the Asus card, the TUF, and 270 microfarad bulk capacitors for input filtering. SIC 639s. I'm assuming 50 or, like, 60 amp power stages, same as what Gigabyte's using from Vishay. Really clean layout in terms of the voltage regulators. I'm guessing... actually, this might be 1.8 volts. Because this looks like it might... yeah, this looks like there's a power plane going to the memory chips. This is probably 5. And then we've got these... actually, wait, no, this is the MSI card. The back. Like, Asus on some of their... oh, they did label them. Oh, so there's a second 5-volt rail. Like, whatever's down here is another 5-volt rail. Because you've got 1.8 volts, 1.2 volts, PEX. I really like the fact that, like, Asus labels the different voltages. Also, obviously, I love what Asus has done with the output filtering, right? Like, we've got 470 microfarad SP caps just absolutely everywhere, and I do appreciate that. There's even some unpopulated pads if you feel like taking it a step further. They didn't bother with the extra multi-layer ceramics that Gigabyte included, right? Like the ones over here and here, but we've got 470s but directly behind the core. Yeah, if this should definitely have the like best voltage regulation of all of the 4070 Ti PCBs that I've seen so far. I'm assuming for the Strix card, they're actually like fully populating the V-Core VRM, because you can see there's 2 power stages that are like missing over here. Also interesting that Asus has decided to sort of deviate from the typical V-Core power plane design and wrap the V-Core VRM like at least partially around the GPU. I don't know how much that actually helps, because if you look at the power plane, right, like you can see that there's this split because we've got like memory power coming in over here from these 2 phases. But then you've got this split, and that then goes up and around. And then this is like the first place where you see the V-Core power plane actually heading towards the GPU core. And the reason for that is like the BGA of this probably, like the way the GPU core BGA tends to be designed, at least for NVIDIA GPUs, is that you'll have like one corner where there's like a lot of V-Core connections, and then directly behind the core itself, you have a lot of V-Core connections. So I mean, this is a multi-layer PCB, so it's entirely possible that like Asus has a internal V-Core power plane that just goes directly from these 2 phases straight into the core, but at least on the top layer, you could see it's kind of taking this really long path towards the dedicated like power delivery corner that NVIDIA has designated on this chip. Which, yeah, that's how a lot of NVIDIA GPUs are designed, is that like all the power is supposed to come in from a certain angle. But hey, if there is an internal, V-Core power connection that goes straight from here to the center of the chip, then this like spread out VRM design might slightly help with power distribution. Slightly. Yeah, maybe. I don't like the thing is like most of the V-Core is still over here, so if you just assumed perfect current distribution between all of the phases, we've got what? Like 9 power state, or perfect current distribution between all of the power stages. We've got like 9 power stages over here, and then 2 power stages over here. So that's 11 in total. So that'll be what? Like, yeah, let's again just say 20 amps per power stage. All right, so you'll have like 40 amps coming from over here while your 180 amps are coming from this side, and it's like, is that really gonna make much of a difference? But yeah, like it like without having the card in hand, like because you could measure that, like the voltage differences between like what's the output voltage over here, what's the voltage over here, what's the voltage over there, what's the voltage over here on the power plane, and sort of get some idea of like the like how much is this actually making a difference. Because if the voltage over here is really high relative to over here, then this is utterly pointless. Yeah, I guess the other benefit Asus gets from this is like this should be compatible with LN2 pots, now that I look at it. Because most of the other cards that we've looked at, if you wanted to strap an LN2 pot to them, like you're not managing it because there's a bunch of like tall components, right? Like if we pull up the MSI card, the Supreme X, like you're not putting an LN2 pot here because you've got these capacitors right here and potentially these inductors. I don't know how tall those are. They might be too tall. Whereas Asus, by sort of, making sure that all of the tall stuff is over here and here, like, yeah, you can put in, like, this is like the only 4070 Ti that you could argue is like actually designed for LN2 overclocking, because you don't have to shuffle any of the components around. When I say shuffle them around, I mean like desolder them and probably not put them back on. So yeah, which, I get it. To most people, putting a 4070 Ti on LN2 seems utterly pointless, but I miss the days. Like, back in the day, it really wasn't that uncommon for people to run, like, a GTX 560 Ti on liquid nitrogen, or a GTX 670 on liquid nitrogen, or a, you know, HD 7870 on liquid nitrogen. Like, so yeah, like I know it's like these days people don't do that because it's like if you're gonna go to the, you know, like if you're gonna go through all the hoops of running a GPU on LN2, you may as well run a 4090, not a 4070 Ti. But yeah, if you did want to run a 4070 Ti on LN2, this one kind of makes it the easiest. Also, it looks like Asus might have a bit more input filtering in terms of multi-layer ceramics for the power stages. Just noticed that that might be a thing. If we compare it to, say, the MSI card. Yeah, you've got like one little ceramic over there. And then on the back, you got one more. Yeah, whereas Asus has like 4. Yeah, you've got 2 on the back, 2 on the front. Yeah, they've got like four multi-layer ceramics per power stage. So I'd really expect the voltage regulation of all the 4070 Ti's. I'd expect this one to have the best voltage regulation. It doesn't have any fuses though, and wait, no, I already have that open. Oh, looks like this phase gets its power from the PCIe slot because you can see there's a split over here. Oh, I think I know how this is wired. So power comes in, goes through this 2 milliohm shunt resistor, goes through this 5 milliohm shunt resistor, and this goes off to the memory phase. So arguably, if you wanted to add fuses to this card, you could do it. Oh, and they've also got some PCIe power going definitely to this power stage. Maybe all 4 of these? Might be all 4 of these, actually. And then these would be on the... Yeah, so... Well, those are the kinds of things where it's like I'd need the card in hand to know for sure. Dual BIOS again. But yeah, like of the 4070 Ti PCBs, this is nice. This is very nice. There's tons of extra... Actually, they've also had like extra multi-layer ceramics. Like, man... See, I appreciate like how Asus just goes to with their GPUs. They generally, well, they have some basic models that are pretty like, you know, not really that special. But once you get to like the TUF cards and the Strix cards, especially, like yeah, Asus does go, you know, that like a step further than the absolute bare minimum of what'll make a functional 4070 Ti, especially when it comes to like output filtering, input filtering, that kind of thing. And I appreciate that a lot, right? Like, yeah, we've got just a ton of SP caps just, like, rammed right up against the memory chips, which is nice. I'm not entirely certain what this one's doing over here. There's no memory chips over there. Like, I feel like this one might be more useful if it was over here than over there, but sure. Might help the memory controller, though. Also, the voltage labels are nice. Yeah. So of the 4070 Ti PCBs that I've seen so far, like the Asus one is definitely my favorite, and it's easy to see why, right? Yeah, we've got 11 power stages for V-Core, so it's only like 1 power stage behind what MSI has on the Supreme X. It's 1 power stage ahead of what we saw on the Gigabyte card. It's 1 power stage ahead of the Palette. Actually, it's like 2 power stages ahead of the Palette card. So, you know, good power handling capabilities. Really nice filtering configuration, both input and output, right? Because this is also on 270 microfarad input filtering caps. Yeah. So the TUF has the best PCB, and if you really wanted to, you could strap an LN2 pot to this without having to worry about like component clearance. I'm assuming the price is not particularly like, you know, after all those upgrades, like what's the price like? Do we get a price? That's not too bad. Yeah, like if you wanted to add all of those capacitors yourself, $50. Well, okay, depends what. SP caps can be very expensive. So you'd probably spend like at least $20 on extra capacitors if you wanted to replicate what Asus has done here. And of course, your warranty would go bye-bye. So what's the MSRP on the MSI card? Obviously, another factor is like the heatsink, right? You can't ignore that. GPUs do come with heat sinks. But if all you cared about was just the PCB the card comes with, then the TUF definitely is the best option right now. At least from what I've seen. Well, there's also a Strix card, which if they just populate the missing power stages, then it's like, well, that's easy. Wait, no, I wanted to check the price for this. 860. Whoa, this is actually more expensive? Well, maybe the heatsink's better. So, yeah, like, Asus, as is kind of the norm, actually. Like, yeah, like, most of the time, I like Strix PCBs. I can't really, okay, no, if you go all the way back to, like, 900 series, the Strix cards weren't really that special. But Strix and TUF cards as of, like, 30 series, or even 20 series, I feel like, have been really nice, generally speaking, in terms of power delivery. So, yeah, I mean, I'm not particularly surprised that, my favorite PCB is the Asus one, as tends to be the norm for GPUs these days. At least, well, for the 4090, my favorite is actually the MSI Supreme X, but yeah, for like the thing is MSI when it comes to the lower end cards just doesn't give them as much attention as they give their top end cards. Right? So no, I do like the fuses. So that's kind of I think the main in terms of power delivery, I like the TUF. In terms of like repairability, I like the Supreme X. And that's it. It's my thoughts on the 4070 Ti PCBs that Tech Power Up has posted so far. And yeah, so big thank you to Tech Power Up for posting high-res PCB pictures. I kind of feel bad for like stealing. Like this kind of feels like stealing their content to me. Even though I've technically been doing this for ages, they like you should check out the rest of their review for more information about the cards, like the heat sinks, right? Like, which arguably more important than the PCB if you're just gaming on the card. So yeah, check out Tech Power Up's GPU reviews. Like they cover like everything basically, right? Like there is a lot of pages in their reviews. So anyway, big thank you to them for providing high-res PCB pictures. And that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. And that's it for the video. So, wait, is it? Oh, there's also the Teespring store where there's like shirts, hoodies, posters, the usual YouTuber merch. And I've also got a Bandcamp if you want to listen to like industrial noise stuff. So, yeah, there's a link to that down in the description below as well. And that's it for the video, for real this time. So, thanks for watching, and goodbye.